This is lesson 8, the second of maybe 3 lessons today, which is pretty fantastic. We're looking at polynomials and what's called repeated factors or multiplicity. The graph that has been presented is the graph of the polynomial x plus 1 times x minus 3 squared. The fact that the graph just runs through x equals minus 1 is a multiplicity of 1. That's one touching point or one cross. At minus 3, it actually crosses twice. It touches and then bounces back. That's referred to as a multiplicity of 2. This was a multiplicity of 1. And then the other multiplicity is a multiplicity of 3. But we'll slide down and take a look at that. Some discussion is presented there. So the multiplicity of a 0 corresponds to the number of times the factor is repeated in the function, and it ends up with some weird behavior on the graph. A multiplicity of 1 is a crossing of the x-axis, like we saw up on top. Multiplicity of 1 is a crossing. A multiplicity of 2 counts for a double root. It actually touches and bounces back, and it gives me the idea of a minimum or possibly a maximum, depending on which way it opens. And then the multiplicity of 3 leads to a concept that is calculus-based, which is called a point of inflection. And sometimes we call this a squiggle or an S curve through the x-axis. This is called a point of inflection, the place where the graph goes from either being concave down to concave up or the reverse. And this overall shape is often referred to as a squiggle, and that refers to a factor that has a multiplicity of 3. And we're going to see some of those factors. Again, we're going to restrict ourselves to polynomials whose c-value is only 1 or -1. Let's turn the page. So it's helpful for you to get this graph on your calculator. Practice entering, get good at that. Double check your entry to make sure that what you've recorded is proper. Got my graph built, and I'm going to sketch it with particular attention to the x-intercepts. I really like this graph. We see the multiplicity of 1, 2, and 3. The multiplicity of 1 is at x equals minus 3. It just goes straight through the x-axis. That's a multiplicity of 1. So when my 0 was -3, my multiplicity of 1, and it just passes through the x-axis or crosses the x-axis. At -1, I have a multiplicity of 2. So at my -1, I have a multiplicity of 2. And that results in the observation of a maximum or minimum. The x-axis actually becomes tangent. That's another way of describing it. So I get a maximum or minimum. Another way of expressing it is the value here is tangent to the x-axis. The x-axis creates a tangent line. In the particular case of -2, I actually have a local maximum. It peaks and then goes back down. And then at 2, I have a multiplicity of 3, and that's called, the description is referenced as a point of inflection. So language we want to get used to, point of inflection. Sorry about that. The degree of the polynomial is 6. That's the highest exponent in the polynomial. And if I sum the multiplicities, it's also 6, and that should always be true. There's one more example down below. Try and enter it in your calculator and see if you can identify how the x-intercepts are acting. So the question gives us some really good ideas about how to set the window. In this one, I don't have it written in factored form, so I actually have to rely a little bit more on my calculator to identify what those x-intercepts are. Your calculator can calculate that for you, but I've got 3 x-intercepts. I've got an x-intercept at -4. I've got an x-intercept at -1, and I've got another x-intercept at 4. And my calculator can help me out with that. The sketch of the graph, -4, -1, and 4. I come down through, touch, go down, and come back. So try to get in the habit of putting those arrows on your graph. If memory serves me correct, I need to add that on my graph here. So that graph should go on for infinity. Slide back down. And now I'm looking at my multiplicity. At -4, that's a multiplicity of 1. It just slid through the graph or cut the x-axis. One time. At -1, I have a multiplicity of 2. I've got that idea of a local max, which can also be referred to as being tangent to the x-axis. The x-axis actually forms a tangent line or just touches the graph. And at 4, I've got a multiplicity of 1. Again, it just passes through the x-axis. Passes through the x-axis. So the degree of the polynomial is 4. The sum of the multiplicities is 4. And now, based on what I know from all of my lessons, I can actually write it in factored form. I have x plus 4. I've got x plus 1. And I've got x minus 4. And one of them has to be doubled. It's the x plus 1 that has to be doubled. So x plus 1 squared. And now the only thing I should check is to make sure that I generate my proper constant and proper leading coefficient. So 4 times 1 times 1 times -4 is -16. And I have a positive leading coefficient. So my C value here is 1. Are we ready for something a little bit more? I've got 15 minutes left before I have to go to robotics. So I'm going to try lesson 9. See you in a bit.